Welcome back to Monroe Tutoring, and if it's your first time, well, just welcome. We're going to jump right in and we're going to talk about molarity today. And let's start off with the definition. What is molarity? Well, we use a capital M to represent it, and so molarity is defined as the moles of solute over the liters of solution. So in other words, it's measuring concentration of a particular solute in a solution. And so if we take the example of salt and water, and we wanted to know the molarity of sodium chloride, which is table salt, in water, we would take the quantity of moles of sodium chloride and we would just divide that by the liters of solution. So we can do a really easy problem, something along the lines of, let's just say if we had, I always seem to use 0.231 moles, and let's do sodium chloride, and let's say that that is going to be dissolved in enough water to make 500 milliliters of solution. So let's just see, 500 milliliters of solution. Now, sometimes they may just say in 500 milliliters of water. And in that case, we can kind of assume that when you add this much salt to the water, it's not really going to change the final volume of the solution. It's just going to remain the 500 milliliters. But they really should phrase it as being enough water to make 500 milliliters of solution. That'd be the most correct way to phrase it. But as we know, questions aren't always phrased in the best way. So now, what do we do with this information? They gave us moles of a solute, and they gave us the volume of the solution. And so if we look at the definition of molarity, they're asking us for molarity in this question, by the way. So let me just write that somewhere. Capital M is equal to question mark, right? That's what the question is asking. What is the molarity of 0.231 moles sodium chloride dissolved in enough water to make 500 milliliters of solution? So we just take our definition here and we're going to plug these things in. So molarity is going to be equal to the moles of the solute. Sodium chloride is the solute. That's the thing that gets dissolved. And so the solute gets dissolved into the solvent, which would be water in this case, to make the solution, okay? So those are some terminologies, some terms that you're gonna need to know, okay? So molarity is equal to the moles, so that's 0.231 moles. And we can write sodium chloride here if we want to, but there's only one compound in question, so it's not that necessary in this case. And then on the bottom, a relatively common mistake would be for students to just throw the 500 mils down there, 500 milliliters, but remember, it has to be liters of the solution, so we just have to do a quick conversion. And you do need to be familiar with the metric system, so you'd have to know that there's 1,000 milliliters in a liter, so we just divide this by 1,000. In other words, we move this to the left 3 times, and so we're going to get this as 0.500 liters, and now we just throw that on the bottom. So we have 0.500 liters, and then we would just do this math. Now, if we're dividing by 0.5, that's the same as multiplying by 2. So our molarity is just going to come out to 0.462, and that's molars of sodium chloride. All right, guys? So that is kind of the most basic version of this problem. Now, what if they gave us grams? They could have given us grams of sodium chloride, and then we would have to do that conversion first, okay? So check out my videos on doing conversions between moles, mass, and molecules. I have one on that. I have one on molar mass. So if you check that out, then you can just combine these two things. We can just take the mass, convert it to moles, and then use the volume that they give us to get the answer in molarity. All right, guys? So this is a quick one. I'm going to do more problems with molarity in the next one. Other types of problems where they give you the volume or they and they give you the molarity and they want the moles and vice versa. So check that out, and I'll see you guys over there. Welcome to Monroe Tutoring. This is molarity part 2, and we're going to jump right in with the question, which is, what volume of 3.50 molar hydrochloric acid solution will contain 10.0 moles of hydrochloric acid? So in the last video, in part 1 of molarity, I defined what it is, which is, remember, molarity is a concentration. It's a measure of concentration, which is equal to the moles of solute over the liters of the solution. Now, in this problem, we are given the molarity and the quantity of moles that we want, and we're being asked for the volume. So just like I did in my molar mass videos, I'm going to rewrite the molarity as a conversion factor, whereas in the molar mass videos, I rewrote molar mass as a conversion factor. If we're trying to go between grams and moles, or between moles and mass, we use the molar mass, right? In this, when we have a volume or moles, and we're given the molarity, we can use the molarity as a conversion factor. Just like we did with molar mass, between moles and mass, we can use the molarity to go between volume and moles, okay? Same idea. And this is gonna make things easy because we can just kind of rinse and repeat for all these different topics in chemistry. We can just rewrite things as a conversion factor and use them to simplify the math and just do dimensional analysis for everything, okay? So let's jump in. We're gonna rewrite this. Instead of 3.50 molars of HCl, remember, a molar is equal to the moles of solute over the liters of solution, okay? And so I'm gonna rewrite this as there's 3.5 moles for every liter of solution, right? If it's 3.5 molar, that means that there's 3.5 moles of HCl and 1 liter of solution. So let's just write that. We have 3.50 moles of HCl for every 1 liter of the solution. And now we just took our molarity and rewrote it as a conversion factor. And now we can just do dimensional analysis to solve this problem. We don't have to flip around formulas. We don't have to memorize anything. We just plug things in and cancel units out, and the units tell us what to do. So, like I taught you last time, we take the given quantity and we put that to the left, and then we're going to make our parenthesis here in order to cancel out the units. So we are given 10 moles of HCl, and we open up our parentheses and we put our fraction bar, and then we take the molarity, rewritten as a conversion factor, and now we just plug it in here to cancel out the units, right? Some people memorize a triangle, and in my early days of tutoring, I used to actually teach that, but I realized people very easily misremembered how to put the variables in the triangle, so they would just get things wrong. Whereas if you just understand how to cancel units, it's really hard to mess it up. So let's do it this way. So I have moles of HCl, and I want to cancel them. So that means this part that has moles of HCl must go in the bottom, right? This unit here has to go down here to cancel out, like I taught you in my other videos. So let's do 3.50 moles of HCl. And on the top now is going to go 1 liter of solution. 1 liter of solution. And they're asking for the volume of the solution that we need in order to get 10 moles of HCl if the concentration is the 3.50 molars. And by the way, that little AQ at the end of HCl just means aqueous, which is just indicating that the hydrochloric acid, that HCl is dissolved in the solution, in water specifically. So let's go ahead and just do this math now. We just write our equals, we cancel out the moles, and we're just going to plug this in. Remember, I never multiply or divide by the ones because it doesn't change the value. So we're just going to do 10 divided by 3.5. 10 over 3.5 is, there's actually quite a few decimal places, but let's think about how many significant figures we want. And again, if you don't know sig figs, check out my videos on that. There's 2 of them, but that has 3 sig figs, that has 3 sig figs. This is infinitely precise, so we don't count that. So we need 3 sig figs. So it's 2.857. I'm going to take that 7, round up the hundredths place into 2.86, and that's going to be liters of solution. And that's liters of solution. All right, guys? So not too bad. If you know how to do dimensional analysis and you've seen my videos on that and the other related topics, then this should be a cakewalk for you. You just have to know that we can rewrite the molarity as a conversion factor and then just put whichever side you need to on the bottom in order to cancel out the units of what you're given. All right, guys, if this helped, please give a like, follow, share, subscribe. Save this for later so you can review again, and I'll see you guys in the next one. Welcome back to Monroe Tutoring. This is part 3 of molarity. In the first part, I defined what molarity is. It's a measure of concentration. It's moles of solute over liters of solution. In part 2, I gave you moles of a solution and the concentration and molarity and asked you for the volume. And now we're going to do the opposite here, okay? So let's read the question. How many moles of magnesium chloride are required to produce 750 milliliters of a 1.63 molar magnesium chloride solution? So we do have to know the definition of molarity, which is that molarity is equal to the moles of solute over the liters of solution. And once we know that, we can just take the molarity and rewrite it as a conversion factor. If you're given molarity in a question like this, you can just rewrite it as a conversion factor and use it to do dimensional analysis. So you don't really have to memorize equations, only the definition of the actual unit. So let's do that. Let's write this out. We have 1.63, and that's moles of the stuff, the solute, moles of magnesium chloride for every 1 liter of solution. 1 liter of solution. And so then we always take the given quantity and put it to the left. And that I've taught you this in many of the previous videos. You should check them out if you don't know, molar mass, dimensional analysis, conversions between moles, mass, and all the other things. It's going to be the same technique every time for these types of problems, because it's far easier to just know dimensional analysis, learn it once, and it's going to help you out for the rest of the course, instead of memorizing, little tricks. Like there's triangles to memorize. How do I do molarity? Do I multiply by this or divide by this to get this unit or that unit? It's very easy to make mistakes like that and to memorize things incorrectly or just forget them and then remember them incorrectly. So I always suggest learn dimensional analysis and you will be golden for this whole course, okay? So let's get to it. We take the given quantity because milliliters is a quantity of stuff that we can have, right? I can have a beaker with 750 milliliters of a solution. You can't have a quantity of just molarity, right? It's a concentration. So it's not a quantity that you're given, it's telling you how strongly concentrated the stuff is that we're dealing with. So again, we always take the given quantity and put that to the left to do the problem. 750 milliliters of solution. So here we go, 750 milliliters of, I'm just gonna write solution here. And then we open up our parentheses and we put our fraction bar, just as I showed you in the other videos. And we have to figure out which side of this is going to go in the top and which side is going to go in the bottom. Well, we have milliliters of solution here, so that doesn't cancel with moles. So it's got to be the other side, but this is written as liters of solution. So there's two things we can do. We can either put the conversion factor to get from milliliters to liters right here, or at this stage in the course, you should probably know by now that there's 1,000 milliliters in a liter. And we can just rewrite this so that we can cancel out the unit that we were given, okay? So let's do it that way. Simplify things. Instead of writing 1 liter, I'm going to write 1,000 milliliters because they are equal, right? So we're going to go and do this. That is going to be 1,000 milliliters of solution. And now we're good to go because that's milliliters of solution. Plug this in, 1,000 milliliters of solution, and the other side goes on top. That's 1.63 moles of magnesium chloride. Close this up and we can cancel out these units. And let's get the calculator and punch this in and see what we get. And guys, if these videos help you, please give a like, follow, share, save it so you can review it again later, as well as checking out my links. If you'd like to patronize me, that helps me to continue making these videos for free. So now let's get to it. We have 750, and that's supposed to be point. So we have, significant figures. If you're not good at sig figs, check out my videos on that. I have two. One for how do you get the sig figs in the first place, and the other one's on how to use them in calculations. So we just plug this in. We have 750 mils times the 1.63 times 1.63 moles, and then divided by the 1,000, divided by 1, 2, 3, and we get an answer with a bunch of decimal places, and we have to know how many sig figs do we use in the final answer. Well, that has 3, and this is kind of infinitely precise because it's defined as 1 liter. So this doesn't have sig figs down here. So we're just going to keep 3 sig figs in the answer, and that's going to round to 1.22, and the unit is moles of magnesium chloride, right? Moles of magnesium chloride, and that's it. All right, guys? So again, you can be given or asked for grams, and then you would just have to do another step here, and you can check out those videos where I teach you how to do these types of things with molar mass or conversions between mass to moles to molecules and all that. All right, guys? So again, if this helps, please give a like, follow, share, save it for later, and check out my links so you can patronize me. Thanks again, and I'll see you guys in the next one.